Hello everyone, my name is Teja and welcome to today's programming session. In this video, we are going to learn one of the most important and interesting basic programs in C, that is palindrome numbers. So before we start coding, let's first understand the concept clearly. So what is a palindrome number? So a number that reads the same forwards and the backward. Like it is a number that remains the same even after you reverse it. For example, 1 to 1. If I reverse a number 1 to 1, I will get as 1 to 1 only. And another example is 1331. So if I reverse this number as well, I will get 1331. So and even 545 as well. If I reverse the number, I will get 545 only. So a palindrome number looks identical from both the sides. So why are we learning this? This program is very useful because it helps you understand core concepts like how to pick the last digit of a number and how to remove digits one by one, how to reverse a number, how the loops work, how comparison works, and fundamental logic for number manipulation, and what are the commonly used in coding challenges, right? So everything. So these are the main building blocks of many other programs. So where are palindromes used? This is a common question for everyone. So palindrome logic is used in many places such as validating ticket numbers, checking IDs, symmetry based problems, understanding numeric patterns, coding challenges, and interviews. So, learning this gives you a strong foundation. So, moving into the program, now that we know what a palindrome is, so let's write the C program to check whether a number is a palindrome or not. So, okay, we will write some piece of code and execute. So, where we can execute? So, where will we run this program? We can run the program easily using online compilers as well. So, some popular ones are programmist.com, onlinegBD.com, replit.com, turboc, and geeks for geeks IDE. So, we can use any platform. In today's session, I will be using programmist.com because it's simple and beginners friendly. So I have a code with me, so I will copy and paste in the program, the platform. So no worries, I will explain you each step in detail. So this is the entire program. So I have pasted here. This is the platform programmist.com. So now the first step here is hash include stdio.h. So what does this hash include stdio.h? This we can call it as an header file. So this line allows us to use printf and the scanf. So what is printf? To print on the screen, and what is scanf? To take the input from the user. It's like adding tools before starting a maths problem. So this is the purpose of hash include stdio.h. Next, what is int main function? So this is where the program actually starts. Every C program begins with main function. And then the next step. Int n comma reverse dn equal to 0 comma reminder comma original n. So these are the variables I have taken here. So n, Why I have taken n? We can take any variable, n, l, s, anything is fine. But here n indicates the number typed by the user. Reverse dn, the number we build in reverse order. Okay, so here I have given the predefined value as 0 for the reverse dn. So the value of this reverse dn starts from 0. And then the next variable is reminder. So in this variable it will store one digit each time. And the next variable is original n. So it will store a copy of the original number. Why? Because we will change n every time. So we must save a copy. So these are the variables. So this is like having one box for the given number, one box for the reverse number, and one box for the temporary digit, one box to remember original number. Okay. So next, printf enter an integer. Scanf percentage d address of n. As I have already mentioned, the purpose of scanf, it is used to read the address of the variable. So printf enter an integer. So the program asks, please enter a integer. So then the user has to give some value here. Okay. So the user types something like 1 to 1 and it gets stored inside the variable n. Next, original n equal to n. Because we will break and cut the number into pieces. So we must remember the full number to compare at the end. So like writing the original number on a paper before cutting it. Okay. And then next, this is the piece of code. This is the very much important part. So I will explain you this in detail. Okay. So while n not equal to 0, a reminder equal to n percentile 10. So percentile is nothing but the modulo operator. Reversed dn equal to reverse dn into 10 plus reminder colon n by division by equal to 10. So now we will see. So n equal to 1 to 1. Anything the user can type. But for example, I am taking here the n value is 1 to 1. So reverse dn equal to 0. This 0 value I have already predefined. So how this logic will work? Now the reminder n I have taken as 1 to 1. 1 to 1 not equal to 0, which is true or false? Yes. 1 to 1 not equal to 0. Yes, it is true. So it will move into the block. Okay. So 1 to 1 not equal to 0. Okay, what are the next steps? Reminder equal to 1 to 1 percentile 10. So this modulo operator gives the reminder. So 1 to 1 percentile 10. So what I will get here? I will get the reminder as 1. And then the next step, reversed dn. Reversed dn equal to reverse dn into 10 plus reminder. Reverse dn, I have taken the initial value as 0. 0 into 10 plus reminder. What is the reminder I have got? 1. So 0 into 10, 0 plus 1 equal to 1. Next, n equal to n by equal to 10. So how can we write it as n equal to n by 10? So n equal to, what is the n value? 121. So 121 by 10 equals to 12. So this is the quotient we got. Okay. So now what is the final n value? 12. So again it will check. What is the n value now? 12. 12 not equal to 0. Yes, it is correct. So it will come inside the loop. So now again the reminder equal to 12 percentile 10. So 12 percentile 10, what is the reminder? 2. And then reverse dn. Reverse dn equal to reverse dn into 10 plus reminder. Now what is the reverse dn? The last value 1. So 1 into 10 plus reminder. So what is the reminder value? 2. So 1 into 10. 10 plus 2 equal to 12. So next step, n equal to n by 10. So n equal to, what is the n value? 12. 12 by 10. I got the value as 1. So again it will check. 1 not equal to 0. Yes, it's true. will come into the block again. Remainder equal to n percentile 10. Now remainder equal to, now what is the n value? 1. 1 percentile 10 equal to 1. And reverse dn equal to reverse dn into 10. What is the reverse dn value here? 12. 12 into 10 plus remainder. What is the remainder here? 1. So 12 into 10 plus 1. 120 plus 1. 121. So now n equal to n by 10. So 1. What is the n value here? 1. So 1 by 10 equal to 0. So the loop stops. So now what is the original number? 121. What is the reversed number now? 121. Now we will go back to the code. If original number double equal to reverse dn, printf percentile dn d is a palindrome number. So what is the original number? Initially we took 121. Now what is the reverse dn? 121. So it will goes to this block. So percentile d, you know, it is a format specifier for int. So percentile d is a palindrome number. So what is the number inside the original n? It is 121. So now what is the output here? I will get 121 is a palindrome number. So we'll check by giving the number. So enter an integer. Now I am giving the value as 1 to 1. See, 1 to 1 is a palindrome number. So now next time I will give another number. We'll see that one as well. Again I am executing the code. This time I am giving as 1442. See, 1442 is not a palindrome number. You can easily know the, if I reverse of a number is what I am getting, 2441, which is not equal to 1442. So I am clearing this. Again I am running the code. Here I am giving as 1331. You know that if I reversal as well, I will get the same value, 1331. You will just cross check. Okay, now I got 1331 is a palindrome number. So I hope you understood this one. So on that completes our palindrome number program. This is a very important concept because it connects directly to other programs we will learn next. So in the upcoming videos, we will explore more number based programs like reverse of a number, Armstrong number, strong number, factorial programs, and many more. So be sure to check out the next video. Thank you for watching, and let's continue learning together. We are diving into another fascinating C program, that is an Armstrong number. So first we will see what is meant by an Armstrong number. So an Armstrong number has very unique property. It's a number that is equal to the sum of its own digits, where each digit is raised to the power of the total number of digits in the number. So for example, 153, it has 3 digits. So we take each digit 1, 5, 3, raise them to the power of 3 and add them up. So 1 cubed plus 5 cubed plus 3 cubed, which is 1 plus 125 plus 27, and that indeed equals 153. So why is it important to learn? So it's a fantastic exercise for honing your digit manipulation skills, figuring out how to break a number down into its individual digits. It gives you great practice with looping structures and using mathematical functions like power functions as well. It also strengthens your problem solving abilities by requiring you to break a complex definition into manageable programming steps. Yeah, and yes, it's another one of those common questions you might encounter in coding challenges or your interviews. Okay, so let's check into the program. So, all right, understanding what an Armstrong number is and why it's a valuable concept. Let's jump into our online editor and walk through the code. Here is our code. Okay. Okay, here is our C code to check for an Armstrong number. Okay, let's walk through it line by line. So here the header files and the main function. So hash include stdio.h. First we include the stdio.h header file. This gives us access to standard input and output functions, specifically printf to show messages on the screen and scanf function to read the input from the user. And next, hash include math.h. This code also includes the math.h library. In this specific program, we are not using any math functions, but it's often included in Armstrong programs if you use the power function. And next, int main function. This is our main function where all the C programs begin execution and then declaring the variables here. So inside main function, we declare four integer variables int num. So this int num will store the original number that the user enters, and then the next variable is int original num. This will be our working copy, like we use this inside our loop so we don't destroy the original number. Next variable is reminder. This will temporarily hold the last digit of the number as we extract it. Next variable is result. Result equals to 0. So this is our accumulator. We initialize it to 0 and it will store the sum of the cubes of the digits. Okay, so these are the variables and their functionalities. And then printf function. Printf enter a number. It's like getting user input. We show a simple message asking the user for input. And next, scanf function. We read the integer the user types and store it in the num variable. And then original num equal to num. So this is a very important step. We make a copy of the user's number and store it in original num. We do this because our while loop is going to break original num down to 0, but we still need the original num at the end to compare it with our result. Okay, next, the whole loop, the while loop. This is the core logic. This while loop is the heart of our program. The condition while original num not equals to 0 means keep running this loop as long as original num is not 0. Inside the loop, we do three things in every cycle. So we'll explain in detail. Okay, this is the logic that I'm explaining step by step here. So initial values means when we have given the user input, the user has to give one number. Suppose if the user gives num equal to 153, so it will save in the variable num, and then original number equals to 153. Why? Because here the condition original num equal to num. So whatever the value we have given in the num variable will be saved in the original num as well. Okay. So then result equal to 0, because we have already defined it, result equal to 0. And now the loop starts. So while original num not equals to 0, here original num equal to 153. 153 not equals to 0, which is true. So it will goes inside the block. So remainder equal to original num percentile 10. Remainder equal to original num. Original num 153. 153 percentile 10. So modulo operator gives this percentage nothing but modulo operator. This modulo operator always gives us the remainder. So here remainder is 3. And then next step is result plus equal to result plus remainder cube. So I am calculating this remainder separately. So as cube equal to remainder. So what is the remainder value here? 3. So 3 into 3 into 3, 27. So and then result equal to result plus cube. Result equal to result plus what is the existing result? Result value is 0 plus cube. Cube value is 27. So total result value equal to 27. Then the last step is original num. Original num equal to 10. So this we can written it as original num equal to original num divided by 10. So original num 153. 153 divided by 10. I get the quotient value, that is 15. So again the condition will check. So original num 15. 15 not equals to 0. That is correct. So it again enters the loop. So remainder equal to original num percentile 10. So 15 percentile 10. So I will get the remainder as 5. And then again cube. Cube equal to remainder into remainder. So 5 cube 125. And then the condition result plus equal to cube. So result equal to result plus what is the existing result? 27. So 27 plus what is the cube value? 125. So total result value is 152. What is the final step? Original num equal to original num by 10. Original num equal to what is the existing original num value? 15. So 15 by 10. I get the value as 1. Again it will check. So 1 not equals to 0 is correct. It will enters into the loop. Remainder equal to original num percentile 10. So 1 percentile 10. I will get the remainder as 1. So cube of 1 into 1 into 1, nothing but 1. Result equal to result plus cube. What is the existing result? 152 plus cube. What is the cube value? 1. 152 plus 1 equal to 153. Now original num equal to original num by 10. What is the original num value? 1. 1 by 10 equals to 0. So now here again the condition checks. 0 not equals to 0, which is false. So it comes out of the loop. It will check return 0. This signals that the program has finished successfully. If they are equal, we print out that it is an Armstrong number. Else, if they are not equal, we print out that it is not an Armstrong number. Let's see. We will execute this code in the compiler. So I am running this code. I am entering a number 153. So here result equals to num. Same I got. So I got as percentile D is an Armstrong number. I have already mentioned percentile D is nothing but format specifier. So 153 is an Armstrong number. So I will try with another number. I am clear this output. I'm running again. I'm giving another number as 147. So the cubes of 147 is not an Armstrong number. So if both are same, we will get the output as Armstrong number. If both are not same, both the means result and the num. Both are not same, we will get it as it is not an Armstrong number. So that's it. So there you have it, our Armstrong number program working perfectly. So we have seen how to break down a number and perform calculations on its digits. Okay, let's move on to our next essential C program. Our next program explores a very famous sequence in mathematics and computer science. It is the Fibonacci series. What exactly is it? It's a sequence of numbers where each number is simply the sum of the two numbers that come before it. The series always starts with the first two numbers 0 and 1. So if we start with 0 and 1, the next number is 0 plus 1 equals to 1. Then 1 plus 1 equals to 2. And then 1 plus 2 equals to 3. And so on. The series unfolds like 0, 1, 1, 2, 3, 5, 8, 13, 21 and so on. It continues indefinitely. So why is this important for us? So it's a fantastic exercise for understanding how loops work, particularly how variables update their values iteratively. It's a fundamental algorithmic problem showing up in many programming contexts. Beyond programming, the Fibonacci sequence appears surprisingly often in nature, like the branching of trees or the spirals of a sunflower, making it a truly captivating concept. So, okay, coming to the C program code. All right, with that understanding of the Fibonacci series, let's jump into our online editor. Anyway, I have the code here. I'll explain. Here is our C program to generate the Fibonacci series. We start with hash include stdio.h for our input and output functions. Okay, in our main function, we declare n. This will store how many terms of the series the user wants to see, and I, our loop counter, and then the variables a equals to 0, b equals to 1, comma next. So this a and b are crucial. They store our first two Fibonacci numbers, which are always 0 and 1. And the next variable next, this variable will temporarily hold the calculated next number in the series. Okay, first we prompt the user to enter how many terms you want and read their input into n using the scanf. Then we print a label Fibonacci series. Now the heart of the program is this for loop. It runs from 1 up to n, meaning it will execute n times to print n Fibonacci numbers. Inside the loop, in each iteration, printf %d, a, we first print the current value of a. This is always one of the Fibonacci numbers. Next term equal to a plus b. We calculate the next Fibonacci number by adding the current values of A and B. Next, A equals to B. We then update A. The value that was in B now becomes the new A. And then B equal to next. And we update B. The next we just calculated now becomes the new B. Don't be confused. We'll walk through step by step. So this pattern of updating A and B in each loop allows us to keep generating the sequence. So after the loop finishes, there is a written 0 just to end the program. So we'll go for clear explanation. Okay. So this is the code. And A equals to 0, B equals to 1 next. And this is the for loop. Okay. So here enter how many terms you want. For example, if user enters the value as 6, so that means we want to print 6 terms. So internally how the loop execute we will see. So the first iteration. So first iteration, that means I equals to 1. We predefined already I equals to 1. And then printf percentage d comma a. So what is the a value now? A value is initially 0. So it prints value 0. And then next equal to a plus b. So next equal to a plus b. Now what is the a value? 0. And then what is the b value? B value initially we have taken as b value as 1. So now the sum is next equal to a plus b. That is 0 plus 1, 1. And next step is a equals to b. Now whatever the value in the b will move to the a. So now the a value becomes 1. And then b equal to next. So what is the next here? 1. So now the b value becomes 1. So output. So what is the output here? Printf percentage d comma a. So what it will print? 0. So the existing value is 0. So output till the first loop completion is 0. And then again it will increment by 1. So now the I value becomes 2. Next again print a. So now what is the a value? See here the a value is 1. So it will print 1. Next equal to a plus b. So a value is 1 and b value is 1. 1 plus 1 equals to 2. So the next value becomes 2. And then a equals to b. And now a value becomes 1 because what is the value assigned to the b? 1. Now the a value becomes 1. And then b value equals to next. So what is the value existing in the next? Next equals to 2. So as of now, what is the output? Earlier print of a 0. Now print of a, that means 1. So for now it will print 0 and 1 by the completion of second loop. Again it will check I less than or equals to n. So till it is true. Now what is the I value? 3. 3 less than or equal to what is the n value? 6. So it is true, right? Next again it will printf percentage d comma a. Now again what is the a value? 1. Because here the a value is 1. It will print 1. Next equal to a plus b. A value 1 and what is the b value? 2. 1 plus 2 equals to 3. So now again a equal to b. What is the b value? 2. Now a value become 2. And what is the b value next? What is the next value here? 3. So now b becomes 3. So what is the output till now? So existing one 0 and then 1 and 1. So again I value will be incremented by 1. Now I value becomes 4. 4 less than or equal to n. What is the n value? 6. So 4 less than or equal to 6, which is the true case. So it will print a. So now what is the a value? 2. And then next equals to a plus b. A value 2, b value 3. So b value next value becomes 5. and A equals to B. What is the existing B value? 3. And then B equals to next. What is the existing next value? 5. So B value becomes 5. So far the output is 0, 1, 1 and 2. And the next again I value will be incremented by 1. So now I value becomes 5. So print of A. So what it will print now? Print 3. So next equal to A plus B. So 3 plus 5, 8. Now A equals to B. That means B value is 5. Next. B equal to next. Next value is 8. So B value becomes 8. So as of now the output is 0, 1, 1, 2, 3. So again I value will be incremented by 1. Now I value becomes 6. 6 less than or equal to 6, which is the true case. Again it will go inside the loop and it will print. Now print a %LD comma A. What is the A value again? 5. Next equal to A plus B. So 5 plus 8, 13. A value equal to 8, B value equal to 13. So what is the output as of now? 0, 1, 1, 2, 3 and 5. Now again I value will be incremented by 1. No. Now it is I value is 7. 7 less than or equal to 6, which is false. So it will comes out of the loop. So as of now what is the output? 0, 1, 1, 2, 3 and 5. So we'll execute and check once. So I am executing this now. So enter how many terms I want. So I'm just entering as 6 because we discussed this. Then enter. So 0, 1, 1, 2, 3, 5. Get the same, right? 0, 1, 1, 2, 3, 5. Okay. I'm clearing. Now I am giving, if I want only 4, I'll get only the value still 4. 0, 1, 1, 2. That's it. So you can see how our loop elegantly generates the Fibonacci sequence just by updating two variables. Understanding this iterative process is key to many programming problems. Okay, let's move on to our next example. We have explored palindrome numbers and how to reverse a string. Now let's put some of that knowledge together as we tackle palindrome strings. So this is another classic problem that's incredibly useful for understanding how to manipulate the text data. So there you have it, our palindrome string. So a palindrome string is a word or sentence that reads the same forward and backward. Like examples, level, madam, race car and noon. If you check the word level string, in reverse also we are getting the same, Level. So that's the reason we can call it as a palindrome string. So where are string palindromes used? Like palindrome strings are used in checking usernames or patterns, validating special text formats, logic building, coding interviews, and string manipulation practice. So okay, all right. Here is our C program to determine if a string is a palindrome. So let's go through each part of this code. Here, header files, stdio.h. The line includes the standard input-output library, so allowing us to use functions like printf for displaying text and scanf for reading user input. Now here we have used string.h. We include the string manipulation library because it provides the strlen function, which is essential for working with string lengths. Int main function As you know, this is our main function where the program's execution begins, and then declaring variables character str of 100. Here we declare a character array named str. This array can hold up to 99 characters plus one null terminator /0, effectively making space for a string of up to 99 characters. And next, int start equal to 0. We initialize an integer variable start to 0. This variable will act as our left pointer, always pointing to the character at the beginning of the string. And then int end. We declare an integer variable end. This will be our right pointer, pointing to the character at the end of the string. We will set its value shortly. Then getting user input, printf enter a string. We display a message on the screen asking the user to type in a string, and then scanf %s str. So this line reads the string entered by the user and stores it into our str character array. So scanf %s str reads characters until it encounters a space or a new line. So this means if the user types hello space world, scanf will only store hello in str. For single words, it works perfectly. So then initializing the right pointer end. So end equal to strlen of str minus 1. Here we calculate the length of the string using strlen of str. If the string is made of length 5, strlen returns 5. Since array indicates start from 0, the last character of a 5 character starting is at index 4. So that we discuss later. So here the completely while loop here. Earlier we discussed the for loop. Now it is the while loop. So this is the core logic. So this loop is the heart of our palindrome check. It continues to run as long as our start pointer has not crashed or met our end pointer. So essentially we are comparing the characters here while moving inwards from both ends of the string. So inside the loop, if str of start not equal to str of end, so this is our comparison. We check if the character at the start position str of start is not equals to the start position is not equals to character at the end position str of end. So if they are different, we immediately print a message that the string is not a palindrome. Okay, so if they matched, we will get that number as a palindrome. And then here start plus plus and end minus minus. So start plus plus, if the characters do match, meaning the if condition was false, we increment start. This moves our left pointer one position to the right, and end minus minus, and we decrement end. This moves our right pointer one position to the left. Okay, it's a bit confusing. Don't worry, I will explain the step by step, then you will understand easily. Okay. So here this is the logic, end equal to strlen of str of minus 1 while start less than end, and this is the condition or logic in the program. Now we have the word level. Here I have taken the string value as level, level. So let's write the letters with their positions. So as you know, index will always start from the 0th position. For L, index position is 0. For E, index position is 1. For V, index position is 2. For E, index position is 3. For L, index position is 4. So end first condition is end equal to strlen of str minus 1. So what is the string length for a word level? Equals to 5, because it has 5 letters, but the last letter is at position 4, because the reason for that is the counting starts from 0. So we do end equal to str ln of str minus 1. So 5 minus 1 equals to 4. Now start equal to 0. So this is the index position. So here what is the letter we have? L. So first letter L. So and what is the end position? 4. So here what is the letter we have? L. So now the condition, while start less than end. This loop means, so continue checking until both sides meet in the middle. Okay. For level, we check letter at 0 with letter at 4. Then letter at 1 with letter at 3. So here 0 means the starting and 4 means ending. And here again 1 means the starting point and 3 means the end point. So when start reaches 2 and end also reaches 2, we will stop, because that is the middle letter. Why we have to stop this middle letter means, because both are same. LEVEL, both in the starting also we have LE and in the end also we have LE. So we have to compare till the middle and then we can stop. So inside the loop, we have to compare the characters. Str of start not equal to str of end. So if the two letters are different, immediately print not palindrome. But for level, we can check. So str of 0 equal to L. So str of end means 4. So both are same, right? L and L. So same. The loop will continue. And then str of 1 and str of 3. So E and E. So both are same, right? So it will continue. So you may have a doubt how we are getting str of 0 here and str of 4. And then again in the next loop str of 1 and then str of 3. See, it will move the pointers here. Okay, initially str of 0, it will start with 0 and then it will increment by 1. So now str of 1. So likewise for here ending as well, str of 4 and then it will decrement minus minus. So str of 3. So this means first loop start equal to 0 and end equal to 1. It becomes 1 and 3. Now start equal to end, because both are same, right? Now the loop stops because we already checked both the sides. So now it is fully working for round 1 and round 2. So all the outer letters match and then the word is palindrome. So we will check by executing now. I'm executing this. So level is a palindrome. Clear gate. Indian's liver. Liver is not a palindrome. So if I give the same name, then only it will execute as palindrome, else it won't give. So there you have it, our palindrome string program working perfectly. So this was a great exercise in comparing characters from both the ends of a string. Make sure you practice this pattern as it's very useful for string manipulation. So let's move on to our next essential C program. The next program is a prime number. So what is a prime number? So as you all already know, a prime number, it is a number that has exactly two factors, 1 and itself. So examples for the prime numbers are 2, 3, 5, 7, 11, 13 and so on. So here the special note is, so here 2 is the smallest and the only even prime number. Okay, so all right, so let's walk through this code for checking if a number is prime or not. Okay, here hash include stdio.h. As always, we include the stdio.h header file for our standard input output functions printf and scanf. and then the int main function. This is our main function where the program starts, and then as usual we have to declare the variables int n. So this variable will hold the number the user enters, and then int I. This will be our counter variable for the for loop, and int is prime equal to 1, and as you know int is the data type here. Int is prime equals to 1. So this is our flag variable. We start by assuming the number is prime. So that's the reason setting the flag to 1, which means true. So if we find any evidence that it's not prime, we will change the flag to 0. And then getting user input by giving this printf enter a number. So we ask the user to enter a number, and scanf percentage d address of n. So we read the number and store it in the variable. So I will copy this, hold on, paste, so it's easy to explain there. Okay, so here the handling edge cases 0 and 1. If n less than or equal to 1, so this is a very important check. So by definition prime numbers must be greater than 1. So if the user enters 0 comma 1 or any negative number, this condition is true. So printf percentage d is not a prime number. So we immediately tell the user the number is not prime, so return 0. So it means we use return 0 to exit the program immediately. So there is no point in checking any further if we know the number is not prime. Okay, so the next condition, the for loop, the core logic. If the number is 2 or greater, the program continues to this for loop. For I equals to 2, I less than n, I plus plus. This loop is designed to check for divisors. It starts our counter I at 2. Since we already know 1 is a divisor, it continues to run as long as I is less than n, because this is the condition here. So it increments I by 1 in each cycle. Next step, if n percentile I double equals to 0, so this is the critical test inside the loop. It asks, is our number n perfectly divisible by the current counter? So does it have a remainder of 0? So if this is true, a divisor is found, like 9 percentile 3 double equals to 0. So E is prime equals to 0. For example, see, if 9 percentile 3 equal to 0, it's an example. I haven't mentioned any number here, whatever I have taken. For example, I am saying 9 percentile 3 double equals to 0. So it means it is prime. So we immediately change our flag to 0. We have just proven the number is prime or not. Okay, and here we are using the break. So we use the break statement to stop the for loop immediately. So once we find one divisor, we don't need to waste time checking for next 4, 5, 6, etc. So after this, there are few final checks, like after the loop finishes, either by completing or by being broken, we check our flag variable. So if is prime double equals to 1 or is prime double equals to 0, nothing but the else block. So now I will explain you by taking an example. So this is the core logic for I equals to 2, I less than n, I plus plus. If n percentile I double equals to 0, is prime equals to 0 and break. Okay. So what is the step 1? So for example here, I have the option enter a value. So once I got that option, I will give the number as input as 7. So then my I starts from 2. So condition is I less than n means loop will run while I is less than 7, because here my value is n value is 7. So the loop will run till the I value becomes 7. So I will take values 2, 3, 4, 5, 6. Why it start from 2 means because my value I have taken as initially as 2. And in the next step, when I equals to 2, we calculate, here this is the step, n percentile I double equals to 0. What is the n here? 7. 7 percentile I means 2. 7 percentile 2 equal to 1. So here the remainder is not 0. Okay, so 7 is not divisible by 2. So it will increment and it will goes to next step, I equals to 3. So 7 percentile 3 equals to 1. It is not 0. Again the I will increment, I equal to 4 now. 7 percentile 4 equal to 3, not 0. So next again I will increment by 1, I equals to 5. 7 percentile 5 equals to 2. Again here also remainder is not 0. Again I equals to 6. 7 percentile 6 equals to 1, not 0. Here also remainder is not 0. Again I will be increment by 1. So when I becomes a 7, the condition is 7 less than 7. So which is false. So the loop stops. So since we never found any case where, so here the loop stops. Since we never found any case where 7 percentile I double equals to 0, we never change is prime equals to 1. So that means 7 is still considered prime. So after the loop, this part runs. If is prime, printf percentile d is a prime number, else percentile d is not a prime number. Since this prime, so the output will be 7 is a prime number. Here why I am getting 7 is a prime number means percentile d is a prime number. Percentage d is a format specifier for int data type. So what is the value I have taken here? N equal to 7. So I will get as 7 is a prime number. So now I will take the different value for the variable n. So now I will take n value equal to 8. We'll see what will happen. So n equals to 8. So I starts from 2 as per the condition. So the loop runs while I less than 8. So I will take values 2, 3, 4, 5, 6, 7. And when I equals to 2, calculate 8 percentile 2. So 8 percentile 2 double equals to 0. So whenever I have divided the 8 with 2, I will get remainder as 0. So that means 8 is perfectly divisible by 2. So this condition becomes true. If n percentile I double equals to 0, then the next two lines run. So is prime equals to 0, mark as not prime, and it will break. So the loop stops immediately because of break. So we don't check for I equal to 3, 4, 5, 6, 7 because we already found proof that 8 is not a prime number. So now the program checks and it will print as 8 is not a prime number. So we'll check by executing this program. So this is the program code I am now executing. Giving now number as 7. So here I got 7 is a prime number. I'm clearing this output and again I am running. I am giving the number as 8, then pressing enter. So here I got as 8 is not a prime number. So there you have it, our prime number check program. So this logic is a cornerstone for many other problems in computer science. We have now mastered a truly fundamental concept in C programming. And now before we wrap up, let's quickly summarize all the amazing topics we have covered today. We are going to revise everything we have learned so far. So we have covered some very important basic C programs that help build strong programming fundamentals. So in this session, we'll take a quick survey of the five main topics. So first one is the palindrome number, second one is the Armstrong number, third one is the Fibonacci series, fourth one is palindrome string, fifth one is the prime number. So this will help you remember the concepts clearly and preparation for exams and understand how these programs actually work. So let's get started. So first one is the palindrome. So it is a number that remains the same even after reversing it. Like examples are 121, 1331, 123, 21. So how this works? So I hope you remember the logic. So we extract the last digit using percentile 10. We build the reverse number. We remove digits using division operator and 10. And finally we check whether original double equals to reversed. If both match, it's a palindrome. If not, it's not a palindrome. So this program teaches us about loops, reminder, and reversing logic. And the next program is Armstrong number. So an Armstrong number is a number whose digits rise to the power of 3. Add up to the number itself. For example, 153. So 1 cube plus 5 cube plus 3 cube. The sum of all the cubes of these individual numbers also equals to 153. So therefore 153 is an Armstrong number. And 371 is also an Armstrong number. So what are the steps included in this program? So extract each digit, cube the digit, add all the cubes. So compare with original number. So what is the logic here? If sum double equals to original, it is an Armstrong number. Otherwise, not an Armstrong. So this helps us practice digit extraction and mathematical operation. And the next one is Fibonacci series. So the Fibonacci series is a sequence where every number is the sum of previous two numbers. Example 0, 1, 1, 2, 3, 5, 8, 13 and so on. So what are the steps we have used here? We started with 0 and 1. We have used a loop. Each new number equals to previous number plus current number. So we have printed the series up to required terms. So this program teaches loops, variables and number patterns. And then palindrome string. So a palindrome string is a word that reads the same forward and backward. Examples level, medium and race car. So what is the logic we have used here? So I have taken a string, use two pointers, one from start and one from end. Have compared the characters and move inward. So if any mismatch, it's not a palindrome. If all the matches, we consider it as a palindrome string. So this teaches string handling and character comparison. So the last one we have discussed is prime number. So a prime number has exactly two factors, 1 and itself. Examples 2, 3, 5, 7, 11. So not prime numbers 4, 6, 8, 9, 12. So steps used in this program are if n less than or equal to 1. So this is the condition we have used. It is not prime. And next step is try dividing n by all numbers from 2 to n minus 1. So if any number divides evenly, n percentile I double equals to 0, it's a not prime, else it's prime. So this teaches conditional logic, loops and remainder operations. So these are the 5 basic and very important programs we have learned so far. So if you understand these clearly, you will find many other programs much easier, because the same logic patterns are used again and again, like loops, digit extraction, string comparison and divisibility. Okay, I hope you enjoyed this revision, and if these videos are helping you learn programming, please support the channel by subscribing, liking and sharing with your friends. So thanks for watching, and I will see you in the next class.